All right, so I want to go over number 17 from the practice problems. If you have the printout, this is actually number 14, just so you know. So one plane at 520 feet is ascending at a rate of 40 feet per minute, while another plane is at 3,800 feet currently, and they're descending at a rate of 120 feet per minute. And there's two things that we're looking for here. We're looking for how long will it take for the two planes to be at the same time. So how long or at the same altitude is the amount of time. And then what will that altitude be? I'm going to call that A. So those are the two things we're looking for. And we can actually make an equation for each of the planes. This is not a distance equals rate times time problem. So the altitude of the first plane is currently 520. I'm looking at the wrong one. That's why I color-coded this. 520 feet in the air. And it's going up. So it's increasing its altitude 4D feet every minute. So every minute that goes by, that's T, it goes up 40 feet. So that's one equation. The other equation is the altitude is currently 3,800. And it's going down because it's descending 120 feet per minute. So every minute it goes down 120 feet. So that's 120 T. Now, those are my two equations. This is my system, okay? Now, to solve this, I would use substitution here because I already have A isolated, so I can just substitute this in for A. So that would be 3,800 minus 120t is equal to the rest of this equation, 520 plus 40t. And I want to solve for t. So in order to do that, I'm going to put all the t's on the same side of the equation. I'll start by adding 120t to both sides, and I'll get 520 plus 160t is equal to 3,800. I still want to isolate t, so I'll subtract 520 from both sides of the equation. And then 3,800 minus 500 is 3,300, minus 20 is 3,280. And that is equal to 160t. All right, and then my final step is going to be to divide both sides by 160. So that's 3,280 divided by 160 to get 20.5. So that means T is 20.5. And in the context of the problem, that means it takes 20 and a half minutes for them to be at the same altitude. So 20 and a half minutes to be at the same altitude. But we also need to know what that altitude is. So I'm going to say, which is how many feet? And then that will be my complete answer. So I just have to solve for feet. I can use one of those two equations I came up with at the beginning. I think the first one's easier. So I'll use altitude equals 520 plus 40t. Okay, and then t is 20.5. So A equals 520 plus 40 times 20.5. And then I'm going to add that to 520 to get an altitude of 1,340 feet. So they are the same altitude of 1,340 feet at 20 and a half minutes.